Good morning, all of you. So in the last class, we have started lens. Okay. So now let's continue the lens part. So in the last class, we have learned these types of lenses, that is convex and concave. Yes. We have learned these types. Concave and convex. This we have finished yesterday. Types, just diagram I have given you. Now, next one, that is lens formula. Lens formula already you know, same like mirror formula, but just minus sign is coming. Sign conventions are same like mirror formula. Okay, so what is the lens formula? 1 by f is equal to 1 by v minus 1 by u, where f is what? Focal length, v is image distance, u is object distance. So f is what? Again I am writing, f is focal length, v is image distance, and u is object distance. U is object distance. So sign conventions I am giving just in a brief. So you can see here, sign conventions. So sign conventions. The first point, that is distances should be measured from optical center. Second point, distances measured in the direction of light are taken as positive, and vice versa. Okay. Next one, distances measured upwards from principal axis Distances measured upwards from principal axis are taken as a positive and vice versa, means downwards negative. Okay, so I will tell you one example here. One example I am giving you so that you'll understand better. Suppose here is a convex lens, right? And this is your principal axis, and this one is optical center. And now here is f1. Here it is 2f1. This one is f2, and this one is 2f. Now suppose object we have placed somewhere here at this point. This is object we have placed. Okay, and if I will draw the ray diagram, then the image you will get something like this. Something like this you will get. And now this is your light direction. This is what light direction. Now you see, so this distance is what u. So u is what negative, because you are taking, this is u, so this should be minus. Yes or not? Yes, from this to this. Why it is minus? Because it is taken in the direction opposite to the light direction. Whereas this side you see in the direction you are taking, so this distance is there, no. This is positive. Next one, this is hi upward, so this is height of object, so this is h naught is positive. Whereas this distance, that is hi, should be negative. H naught should be positive. U should be negative. Understand? You can write in a bracket. That is U is negative 5, because if you will consider this optical center, you are measuring this distance against the light direction, and this distance in the direction of light. That's why V is positive, U is negative, H naught is upward from the principal axis, HI is downward from the principal axis. So this is negative, this is positive. So I hope you understand the sign convention. This is what light direction, light direction. So if you will read above sign conventions and if you will see the diagram, then you will easily understand the sign conventions, and that from that you can use in the lens formula. Okay, understood? So note down this. Okay, next. Now magnification. Okay, what is next? That is magnification. Same how we have learned in the mirror, same like that in the lens also, that is magnification. So again it has two types. One is lateral, then next one is longitudinal and angular magnification. So first one, that is lateral magnification. Lateral magnification. Lateral magnification, we have to use which formula? M is equal to hi by h naught, which is equal to v by u. In mirror it is minus v by u, here it is only v by u. Keep it in mind. Second magnification, that is longitudinal. So longitudinal magnification, when object is placed along the principal axis, keep it in mind. This is the meaning of longitudinal magnification. So in this you are getting ML, that is longitudinal magnification, is equal to v square by u square, and that is equal to dv by du, also equal to m square. That is this lateral magnification square. Keep it in mind, this formula in mind. Okay. Next one is third one, that is angular magnification. Angular magnification. Angular magnification means what? First of all, if suppose this is a lens and this is your principal axis. This is a lens and this is your principal axis. And suppose object is somewhere here making some angle, and its image is getting from somewhere here, and that is making some angle theta 2 with the principal axis. Something like this. This is suppose theta 1, and this angle is something theta 2. Then here this is object, and this one is what? Image. So in this case, whatever you are getting, that is gamma is equal to tan of theta 2 divided by tan of theta 1. This is what your angular magnification, right? Next one, for several lenses, for several lenses, m is equal to m1 into m2 into so on into mn. Okay, this is what note point number one. And second one, 1 by f is equal to, we know 1 by v minus 1 by u. But in that, if you want to use direct formula from this, so from this point number A, that is if you want to find v directly, then v is equal to u f divided by u plus f. From this formula only you will get this all. And next one, if suppose you want to find u, then u is equal to phi f divided by f minus phi. And if you want to find f, then f is equal to phi into u divided by u minus phi. Okay, so this is a is equal to, or a is what? Phi uf by u plus f. B, u is equal to phi f by f minus phi, and f is equal to phi u by u minus phi. Okay, this is what your note points, you can take it as a. So if sometimes they are asking you direct, then you should be able to use these type of formulas for better calculation, or it will reduce your time. Got it? Okay. Note down this all. Next one, image formation, that is in case of convex lens and as well as concave lens. So let's see image formation. Image formation in case of convex lens. In case of convex lens. Image formation in case of convex lens. Okay. So let's see how it is. First one I am taking in case of convex lens. Convex lens. So in the case of convex lens, we are having total almost 6 cases, right? So I am directly dividing this compartment or this complete board into 6 parts. So these are the 6 compartments I made for this ray diagram. Okay. So see in the first case where I am keeping object I am keeping at infinity. O means object, so object is at infinity, image at f2. Okay, image is where at f2. Let's see here. These are the parallel rays which are coming from infinity, and then the image is forming here like this. Got it? You can draw like this, and this is your f2. Okay, because here somewhere you are getting f1, and here it is f1. Even somewhere here it is 2 f2. Okay, object is at infinity, image is at f2. In the second case, this is your first case. This is the first diagram. You can call it as A. Next one is, this is B. So in this B diagram, I am taking object is between infinity and 2f1. Object is between 2f1 and infinity. Image is between f2 and 2f2. Image is between 2f2 and f2. So let's keep the object now. So this is your object. So I am keeping here because it is saying 2f1 and infinity. So beyond 2f1 I am keeping here. Can you see? This I have kept object because this is your 2f2 and this is f1 actually. This is f1. This side we are giving it as a f1. Okay. This is 2f1 and this one is f1. This side it is f2 and this one is 2f2. So here image you are getting between f2 and 2f2. Real inverted. Okay. And diminished we can. That's somewhere we are getting image. Let's complete this. First ray will go parallel and through the focus like this. Second ray, which is going through the optical center, will go like this. Nature is what? Real, inverted, diminished. Nature is what? Real, inverted, and diminished. Here also real, inverted, point size. Here it is real, inverted, and diminished. Okay, you can clearly see how it is. Next one again, here it is f1. This one is 2f1. Here it is optical center everywhere in the middle. You can keep it in mind. So this is your O. And object I am keeping at 2f1. So here it is object. So the image is forming. So here it is the image. It is of same size. Okay. So this is C diagram. So O is at 2f1 and image is at 2f2. This one is f1 and this point is what? 2f2, where you are getting this image, right? Next one. Now in between 2f1 and f2, this is D diagram. Object is between 2f1 and f1. Image is beyond 2f2. Beyond 2f2. Let's keep object. So before that, suppose this is your f1. This one is 2f1 and this object is placed now here. So when you are placing object here, how rays are going, you can see here. So this is going like this, and then this is going, and somewhere it is getting inflected somewhere here. Somewhere here image is getting formed. You can see here, this is your image. So little enlarge you keep. So here is your 2f2 and this is your f2. The image is what? Real, inverted, and magnified or little enlarged. Okay, little enlarged. Little big you keep. Okay. Next one, that is E. Object is at F and image is at infinity. Where is object? At F1 we can say, and image is at infinity. So here it is your F1 and here it is 2F1. Here it is F2 and this one is 2F2. So let's keep the object. This is the object which is at F1, and now the rays which are going like this. First ray, so these two rays are almost parallel, you can see in the diagram. They will meet at infinity. Okay, here they will meet at infinity and therefore the image is at infinity. Next one, this is also magnified, real, inverted and magnified. Real, inverted and enlarged करके भी लिख सकते हो, enlarged, okay, or magnified, magnified so much. Next one, here it is F1 I will write below so that it is easy for you to draw the diagrams. This is F1, this one is F2, that is 2F1, and now keep the object in between F1 and optical center. So here it is your optical center. So when this you are keeping, how you are getting image, let's see. The first ray will go parallel like this, and like this. Another ray will go like this, and if we will extend these rays, so these rays will meet here, and this is what your image is getting formed behind the mirror. That is virtual and erect. It is not actual image, this is just virtual, not real image. That's why I'm denoting this also with dot dot dots, and these rays will go like this. I already explained virtual object and virtual image concept, so same this is also virtual image, and this is F1, that is object is between F1 and O, between F1 and O, and image is behind the mirror or behind object, and virtual, erect, and enlarged. Got it? This is what image formation in case of convex lens. Next one, in case of concave lens, second one, that is in case of concave lens, there are only two cases. There are only two cases, so I'm making like this chart for convex lens, concave lens, not convex. See here, the first one, that is when object is at infinity. Object at infinity, image is at F, same like concave lens, convex lens only. So let's draw the diagram. Okay, so here you can see this is optical center, and now object is at infinity, so these rays are coming from infinity, and then they will diverge like this. So if we elongate them, they will meet like this. Even this way also it will meet here. But this is what? Virtual meeting. Okay, so that's why I'm denoting with the dotted lines again. Can you see? Yes. So this is what your focus is. Yeah. And that's why object is at infinity, image is at F. So this is virtual and erect. Virtual images are getting formed. Next one, the B diagram, that is B diagram. Object is between infinity and O. Anywhere you keep object between infinity and O, image will form between O and F. Means somewhere here. Okay. So let's see how it is. So let me draw the diagram. Now let's keep the object. So this one is suppose F. Okay. And the object is anywhere you keep between infinity and O, anywhere you will keep. Suppose let's say I'm keeping here. I'm keeping like this. Then this first ray is going parallel to the principal axis, and then it will diverge like this, and this ray will meet at focus like this, right? And another ray which is going through optical center, it will pass undeviated. So if you will see this part, this ray which is imaginary. You can see here it is getting from image. And here you are getting image. That is also virtual and direct images. What type of nature? Virtual and direct. Here also virtual, direct, point size. Here it is virtual, erect, and diminished. This is what the nature of image formation in case of concave and convex lenses. Got it? So this is what your optical center. And if you want here, you can keep it as a F1 also. Here it is F1. So you keep here also F1. If you want to indicate here also F1 and this is 2F1. This one is F2 and 2F2. So here also if you want, you can keep F2 and 2F2. So you change here like this, image at F1. Got it? Anywhere you keep, you will get image here only. So these two cases are possible in case of concave lens. Right? So let's stop here for today. Enjoy the day.